Hello everyone, my name is Hao Tian, and today I'm going to present a paper about attention management system. So here's an introduction. So what exactly do we need to talk about attention management system? So with the emergence of mobile computing devices has radically changed the way we communicate with each other, and also we receive a lot of notifications from such devices. Usually these mobile devices will often proactively deliver this information to us. For example, the online social networking applications can keep us up to date with other users' reactions, such as on Instagram, your friend like a photo of you, or if your favorite YouTuber just published a video. And the retailing apps can send us no discount offers as we approach their store according to our GPS location. And also, the apps like Google Calendar can remind us of the upcoming events during the day. Although this kind of information provides support for multitasking, and we can also utilize our time better if we know what is upcoming events in the day will be like, or a delay might be happen, then we can plan our time accordingly. But it often results in fragmenting a user's attention, and this usually has devastating effects, such as reducing work performance, increasing task error rates, and reducing stress. And in extreme cases, a user may be too annoyed by this notification that he or she may just uninstall the application. So it is really down to the application developers to design an effective attention management system to ensure that ubiquitous computing naturally supports instead of interferes with our everyday life. So what exactly is attention? When we think this attention is just someone focused on something, but here we give a more detailed definition of attention in cognitive science. So there are mainly two popular definitions of attention. The first one is a selective process of incoming sensory information with limited capacity and a reactive and deliberate process. So in this concept, the author in this paper tries to think the human brain as a pool of buffers. And this buffer can only take a certain amount of sensory information, such as light, vibration, or sound. And the second concept is the ability to ignore the irrelevant information. The authors in this paper chooses to focus on the second definition because the user usually can just decide to accept or ignore the notification. And they consider attention as an internal cognitive process that allows the individual to select tasks or information that will be actively processed. So here we have a diagram about interruption models and effects of interruptions. So we can see in this diagram, a person is continuing on his or her primary task, and then interruption happens. The first step of the reaction of the user is to process interruption. So the time will be spent on interruption lag, and then the user can choose to accept interruption and continue on secondary task, such as here, or he can uh, just ignore the interruptions and continue on the primary task. And if we choose to ignore, then there's going to be a resumption lag where the user needs to recover the memory from the primary task. So as we can see, this is a very time-consuming process because the user not only need to deal with the interruption, but also need time to recover the memory. However, we find that the secondary task, if delivered as in form of notification, it will be completely faster because the user always wants to go back to the primary task. And however, the error rates of the secondary task will increase even though the time of the secondary task will be reduced. And then here we continue on designing successful attention management system. So here, give a definition of attention management system as a system that computationally seeks to balance a user's need for minimal disruption and the application's need of efficiently deliver information. As we talk about, the interruption is very time-consuming. However, the research found that if we don't deliver notifications at all, the user may induce even more stresses as being interrupted constantly. So the key point here is we need to design the attention management system so that it does not interrupt the user too often. So here we have the sensing stage, where the attention management system gathered data from the sensors on the mobile devices, and then do the processing of that data, such as normalizing and data cleaning. And then we can infer what kind of activities the user is doing from the sensory data. And then we can kind of using machine learning model to give a user a detailed profile of interruptibility level for each kind of notification for a user. And then the attention management system will take over to handle the notifications for the user in the future. Here, I want to give a more detailed explanation of the data gathering process. So in general, it is split into two stages. The first stage is the feature generation stage, where we can, as we can see here, the mobile devices can gather all kinds of sensory data such as GPS, Wi-Fi, microphone, application usage, and gyroscope, and store that data locally, and then send to the attention management system to process that data. And we can get features from that. And then with these features gathered, we can feed them to machine learning models and train on them, such as if the user has stopped running, or the user started watching a video, or the user constantly checking the app, which means the user is sort of in an anxiety mode. And then we can sort of use that feature to train different classifiers or logistic regressors to derive the user's mental workload or physical activities. Here, I'll give an example of the state-of-the-art attention management system. It's called Artilia 2. As you can see, the Artilia 2 runs on both platforms, such as Android Wear 5 and the Android 4.3, both on mobile and wearable platforms. And Artilia 2 monitors acceleration signals and application users to infer posture and locomotive activities of users. For example, if the user stopped walking and sitting or standing. And why the system gather these breakpoints? Because it thinks the best time to send the user's notification is between two separate tasks or two separate physical breakpoints. If the Artilia 2 cannot find such breakpoints, say the user has been reading for a long time, it can also detect the natural breakpoints during that activity and send the notifications at that time. And here's another example of the attention management system. It's called Interrupt Me. So here, the developers took a different approach by proactively surveying the user about their emotions while the notification being sent. Here, they do a survey every time the notification is sent to the user of the time and accelerometer and the location. And the user have to answer whether he has company, aka he is alone or with friends. And also the activity engagement of the user, like is he doing work-related stuff or just doing some leisure fun stuff. And the most importantly, the emotions of the user, is he happy, sad, angry, or neutral? With a lot of sampling data set, the Interrupt Me can build a very detailed profile of a specific user, and can even update, the user can ask the app to re-profile his preferences by we're doing this kind of service to give the app up-to-date information about the using habits. So as a summary, generally we have 3 different approaches in managing the interruptions. The first one is mediating, meaning deferring the notification to other breakpoints. And the second one is mitigating, meaning we can send the notification not on the mobile devices, but on other devices such as Internet of Things infrastructure. And the third way is, to indicate the interruptibility level of this specific notification to the user. And the most used strategies is the first two. So what is the future in attention management system? So first trend is more advanced wearable devices that will enable the sampling of more complex biological signals, such as blood oxygen, like eye movements, to determine the user's mental workload more precisely. And the second trend is the usage of enhanced edge computing. As the mobile devices gets more computing power and storage, we can actually store a lot of that data locally without sending them to the cloud, so that will ensure the privacy and also more efficient. And the third one is sending a notification via Internet of Things devices. The research has found that if we send a notification in other forms, such as changing the ambient light or displaying a small message on the smart TV where the user is watching like a video, this will significantly reduce the user's interruptibility level. So in summary, by leveraging the unique characteristics of ubiquitous computing, such as personalized information, always-on connectivity or sensing capabilities, combined with cognitive and psychological concepts, the attention management system can help reduce the interferences of the ever-increasing number of interruptions we see on mobile devices. And here is a list of references I've used. And thank you for watching my presentation.